Chapter 21, Example 3. In the December 2002 issue of Consumer Reports, Consumers Union reported on their investigation of the presence of bacteria in packages of chicken. They purchased both name brand Perdue and store brand chicken in 25 U.S. cities. Lab tests found Campylobacter contamination in 33% of the 75 Perdue packages and in 45% of the 75 store brand packages. Does this indicate that shoppers would be safer buying the name brand product? So we're saying, does it indicate there's a difference between them? Again, this is a hypothesis test. We're not saying what is the difference. We're saying, is there one? So we'll do a full hypothesis test. We'll define our variables, do the hypotheses, check conditions, use technology to find all our statistics, and then state a conclusion at the end. So P will represent Perdue brand packages of chicken. S will represent store brand packages of chicken. So our null hypothesis will be that the proportion of Perdue minus the proportion of the store brand equals 0. So P of P minus P sub S equals 0. Again, we're saying there's no difference. And generally, that's what you should have in a 2 sample, is it equals 0 for the null. The alternative, we're saying that the Perdue is better, which in this case means they have a lower percentage of contamination. So P minus P sub S is less than 0. So that difference between them is less than 0. That would indicate that Perdue packages have less contamination. Their percentage of contamination is lower. Now we'll check the conditions as usual. Though random assignment is not mentioned, I will assume Consumer Reports used randomness and proper sampling design. That's what their business is. They check out products so they know proper design methods. We'll assume they're using the right ones there so they can give an unbiased opinion. 75 packages of Perdue chicken and 75 packages of store brand chicken are both less than 10% of all packages of their respective brands. Now the independent groups is a little bit tough here. We just want to make sure because one store might handle chicken differently, so both the Perdue and the store brand would be more likely to have bacteria. So as long as the packages of each brand were not purchased at the same store, we'll have independent groups, so we don't have to worry about that mishandling by stores. So as long as they're not all purchased from the same store, we're good. 25 Perdue packages of chicken had contamination. 50 did not. Both at least 10. 34 store brand packages of chicken had contamination. 41 did not. Both at least 10. The conditions are met. I will use the normal model for a two-proportion z-test. There we go, conditions are done. Now we're ready to move on to our calculations. Again, use technology, you don't want to do this by hand. So, our sample size for Purdue was 75, so N sub P is 75. The sample size for store brand was the same, so NS equals 75. Now let's find out those statistics. So XP, the successes, in this case, which is getting bacteria, was 25. And X sub S, for the store brand, 34 of those had bacteria. Okay, so looking at the normal model, zeros are difference. We want the difference to be negative here, so we're actually looking at the low side. We would do those proportions, which is 0.33 minus 0.45. Which gives us negative 0.12. And then we're shading to the left. Everything to the left is what we're looking for, so if we looked it up in the table, we would just be interested in exactly what we come up with. Now let's use the technology to run our calculations. Again, do a new document, calculator page, go to menu, statistics, stat tests, and again we stated the test we're going to use, so pick that, a two-proportion z-test. Put in our statistics. So 25 successes, 75 in the sample. So 34 successes and 75 sample size. We want P1 to be less than P2 this time, so we'll pick the bottom option. Hit OK, and there we go. Our z-score is negative 1.50, and our p-value is 0.066. Now we'll write those statistics down. Always show them. Go ahead and show your z-score and your p-value. So z equals negative 1.50. Our p-value is 0.066. So now we can state our conclusion. My p-value of 0.066 is above and alpha of 0.05. And I will fail to reject the null hypothesis. There is not sufficient evidence to show that name brand chicken is less likely to contain contaminants than the store brand. Now, if you think that 0.066 is low, and you want to say, oh, I will reject the null hypothesis, that's perfectly fine. There's no certain cutoff. As long as you can discuss it intelligently, using the proper statistics language, you would be absolutely fine. If you say, I will reject the null hypothesis, then you're perfectly fine. If you do that, go ahead and show a confidence interval to see what you think the true value is or what you think the difference should be. So if you reject the null hypothesis, do a confidence interval to find out that difference.